Hello everyone, welcome to AI Programming with Python Nanodegree. My name is asheem.chhetri and I'm a recent graduate from Purdue University with my bachelor's in computer engineering, entrepreneurship, and a minor in economics. So today what I'm going to do is that I would like to talk about this program, AI Programming with Python Nanodegree, which comes from Udacity, and basically go over the program, giving you guys a little bit of taste of what to expect in upcoming classes, and talk a little bit about the final project, which is designing your own image classifier, which is very exciting. So yeah, let's go ahead. So there are various classes in this program, like Introduction to AI Programming. It basically talks about what is artificial intelligence, what to expect, and what you will be learning. And the second class is on Intro to Python. To be honest with you guys, this was one of my favorite class because I already know Java, C, and C++, and when I was learning Python, it was like so super easy because it's very, I think I can say, like user friendly as compared to other classes. So this is a really fun class. And one thing that I would like to point out is that when you reach this lesson number 6, which is a lab called classifying images, I would like you guys to focus on this a lot. Even though you won't be designing your own neural network, but this lab teaches you a lot about how to write your own clean and nice Python scripts. So following good coding practices will help you in future, not only for this class but for other classes, or your own real life job or any project that you will ever work on. Then going forward, class number 3 is about NumPy, Pandas, and Matplotlib. So over here, we learn about Anaconda. It is basically it installs a version of Python on your computer without you worrying about the libraries. I mean, you don't have to worry about anything. It installs everything that is necessary. And if you need something, this class talks about how to install specific libraries. And then going forward, Jupyter notebooks. The way I think about Jupyter is basically a big web application where you can code in Python. I mean, you don't have to worry about anything. You don't have to install anything. Just install Jupyter and you're good to go. And going forward, we have NumPy, which is a libraries. And it is really important library in Python because it can help you to process or process or do mathematical computations in a very fast manner. Like if you do the same thing in a traditional way in Python using a bunch of for loops, while loops, it will consume a lot of resource and it can take a lot of time. But NumPy has it all figured out and it's kind of super optimized. And then Pandas is basically I really think of it as a glorified CSV processor because I mean, it is coder friendly and you can do a lot of stuff with it, and you can open huge files with Pandas, and it is also optimized and it's also very fast to work with. Going forward, you will learn about Matplotlib and Seaborn, which is basically a way for you to visualize your data. So for example, if you open a data set using Pandas, then you can uh, use any of the Matplotlib or Seaborn inbuilt features, for example, histogram or line graph, to visualize the data that you're getting from Pandas data frames. And going forward, class number 4 is all about linear algebra, and this is basically all the basic stuff that we have already learned in high school or in freshman college level classes. And then class number 5 talks all about neural networks, which is the most fun thing that happens in this class because it talks about how you can design your own neural network, how you can minimize the errors, softmax functions, ReLUs, dropouts, early stopping, and stuff like that. I mean, this is really fun. And one thing I would like to point out is that this class, at the time of this recording, and when I finished this class, was done on PyTorch 0.3. And currently, I think in the market, PyTorch 0.4 is already out. So I'll say stick with the version that they have in the class. Maybe you guys will be using 0.4, but just so a heads up for you guys, because there were some issues when in our class when we tried to move from 0.3 to 0.4, and I figured it out during the discussion with other students in the Slack channel that, like, most of the time the files were not working. So focus on, like, what the instructors already have in the program. And last but not the least, let's talk about the final project that you guys will be working on, which is designing your own image classifier. So for this one, I'm going to talk about this project through my own GitHub repo, which is over here. So as I said earlier, in this final project, we'll be using PyTorch, we'll be using Jupyter, and Python, specifically this version 3.6. But the overall gist of this program is basically you create a neural network which helps you to, like, determine or, like, figure out the image, or basically you can say it can do image classification for you. And in this project, there are 3 different data sets, basically called, here it is, training data set, validation data set, and testing data set. So why do we have 3 different data sets? It is basically because, like, when we start training our model, we feed it this data set, which is called training data set. And while we are training, we provide it with this validation data set just to make sure that we are on the right track, and we can do that by looking at the accuracy that we're getting between these 2 data sets. And last but not the least, once you have completely trained your model, you then need to feed this data set to your already trained model just to see that, like, your new model is perfectly fine and is good to go. So basically what happens over here is, I'll try not to talk about too much about the technical details, but I'll try to give you a rough idea. So when I was doing this project, I used DenseNet one-to-one architecture, which was already designed by someone else. So what happens is that you load a pre-designed new architecture in your code, and then you modify some of the parts of it. So for example, over here I changed the classifier so that it suits my own needs. So we have input size of I think for this one it was like 1024. This 500 and 200 is basically like hidden layers, and you guys will be learning a lot about hidden layers in further classes. And then log softmax is just basically the output, so that, like, your output falls between 0 and 1. And then we have optimizer criterion, and that's it. Like, and then this talks about, like, another classifier. So this one is much more simpler, to be honest, much more simpler than this classifier. And what else do we have over here? So yeah, in the program you will be writing multiple scripts. One will be train.py, which basically, like, allows you to train your model on the testing and validation set, and it has all the instructions on what you need to do over there. So that is there. And then finally there will be predict.py file in which, oh, I forgot to mention that, like, in train.py you will be creating a file called checkpoint. So basically the concept of checkpoint file is that, like, every time you train a model, it takes a lot of time and resources, especially the GPUs, graphics processing unit. So if you don't do the checkpoint, if you don't save your model in a checkpoint file, then every time you have to retrain the model, and you can imagine, like, how expensive that is in terms of your time and resources. So when you're training your model, and you are certainly, like, 100% sure that, like, that you like at whatever accuracy your model is trained, you save your model in a checkpoint.pth file, and in this second Python script called predict.py, you kind of open this file checkpoint.pth in this file predict.py, and then you just use this like pre-trained, or I may say, like, already trained neural network by feeding it the test data set, and it depends on the way you have already coded your predict.py. It just tells you, like, that, hey, like, you passed me this data set, so this is how good is your model, and it gives you the prediction. And I'll show you guys later that how it looks like. So basically these are the data sets. So the first one is training data set, and the second one is the validation data set. So these two go hand in hand whenever you're training your model. So basically, like, validation data set helps you to like make sure that your model is getting trained on the right level. And last but not the least, here's the testing data set, which you usually feed to predict.py. So it basically tells you how good was your model based on the prediction it can do. So yeah, here's the result. So in my case, I trained the model multiple times because I was also enrolled in PyTorch scholarship program. So this first one, um, the one with the prediction of 89%, was the one that I did for AI programming with Python Nanodegree. And as we can see that, like, this flower that I've given as an input, it says that probability of this flower being a pink prime rose is 10.22%, which is absolutely wrong because this is pink prime rose. While looking over this one, which had a prediction of accuracy of 99.28, so we can see that, like, when I feed the same flower to this model, it it can easily tell me that, like, that, hey, the probability of this picture being a pink prime rose is 99.86%, which is what we want. And there's one thing that I would like to specify, is that first, focus on getting all the requirements of the Udacity final project rubric to be completed, and then only focus on improving your model. Because if you try to focus on doing that on get-go, it can consume a lot of time, and you have a limited GPU hours on Udacity servers. I think it is only 58 hours. So be careful of that. And once you have something like this, like, with some prediction, and like, you have a working model and you satisfy all the requirements in the grading rubric, then you can go ahead and, like, you can play around and try to, like, improve your model to something, like, better. And as you can see here, I just show you guys, like, a difference between, like, my first model and the second model. So for this one, this flower, it can actually predict, like, hey, that this is barbiton daisy. But for, like, this flower, trumpet creeper, we can see that, like, 89% accuracy model is still kind of struggling because it says, like, it can be this one, this one, this one, while as the 99% one is right on the point, right? Same goes for this flower. And so what you can do from here, oh, by the way, this is how the certificate looks like. So once you have the checkpoint file, you can, like, actually integrate those checkpoint file with the web application, mobile application, and, like, possibilities are endless. So once you design your model, you can do a lot with it. And there are, like, a lot of data sets online. So you can, like, you're not required to just work with, like, flower data sets. Like, once you finish this class, you can, like, pick up any data set that you're interested in, which could be related to, like, health, cars, bikes, anything, and work from there. So yeah, and the possibilities are endless, and I hope you guys are as much excited to work on this fun project. And yeah, and we'll go from there. Thank you.